Okay, welcome back. This will be the last video in this little section of the textbook. So this is dealing with the intersection of two lines. And what that essentially means is we're going to be given two equations and they will represent two lines in the number plane. So any two random lines. And we essentially are trying to find the coordinates of the point that the two lines cross. The only situation where this can't be done is if we have two parallel lines, because they will never cross. And that will be indicated by two lines with the same slope. But we shouldn't have to deal with that. So as long as the two slopes are different, then we'll have no trouble. So essentially this is going to have a positive slope, this is going to have a negative slope. That sort of makes it easier. And there's only going to be one point, one set of coordinates where this line is equal to that line. So that's a little clue in how the easiest way to solve these. We find when the two lines equal each other. So I'm just going to jump straight into an example. So that, well, first one, y equals 2x take away 5, and y equals negative 3x 10. So there's the two lines, and we want to find the point that both of these lines intersect. So essentially what we want to do is we want to know when this and this are equal. So as long as they are both rearranged in this y equals something x plus or minus something, then we make this part of the equation, just the x sides, this bit, equal to that bit, and then we solve to find, and that will tell us what this x value is. So we write it out, 2x take away 5, and we want to know when it equals negative 3x plus 10. So we've sort of seen stuff like this when we were collecting like terms. Some of the more complicated ones where we were just solving for x. Yeah, so once we've made one equation equal to the other, we essentially want to solve for x. So that means collecting all the x terms on one side, the number terms on the other, and if we've got more than one x, then we just divide through. Hopefully that makes sense. So because this one's negative, I'm just going to add that to both sides. So over here it cancels out. 2x plus 3x is going to give us 5x. We've still got this take away 5, and that equals, we've got nothing there, so that just equals 10. And then bring this 5 to that side by adding 5 to both sides. So over here that cancels with that. So we get 5x equals 10 plus 5 is 15. And then we'll divide both sides by 5 because we've got 5x. So that cancels with that, and we end up with x equals 3. So that's the first part of what we need to do. So that means, let's just hypothetically say those two lines, they don't represent these because one of them passes through negative 5, but that means the x coordinate, or of of where these two lines cross each other is x equals 3. So the final step is to then substitute x equals 3 into one of these equations, and it doesn't matter which one. In fact, if I put a dotted line, we'll do both of them just to show that they both give y equals the same thing. And then that will tell us that the coordinate that they cross is 3, 3, whatever we work out here. Sub into one equation. Okay, so we'll do the easy looking one first. So y equals 2 lots of this, 3, take 5, 2 times 3 is 6, take away 5 is 1. So we should end up with 3, 1. Now just to show you that it doesn't matter which one we choose, negative 3 lots of 3 plus 10, negative 3 times positive 3 is negative 9 plus 10, that equals 1. So these two lines intersect at the coordinate 3, 1. I think that's the easiest way to... So you only have to do one of these, but I just did the second equation just to show you that it doesn't matter which one you pick. So I would tend to pick, because that was negative, I would have gone for this one. So we've got another example. Alright, so let's get rid of that. This is just going to be a very short video. So y equals negative 4x plus 6 and y equals 2x take away 12. Right, just so that we can get some idea of what we're going to be dealing with, I will try and draw a slightly more accurate representation. So this one passes through positive 6, let's say that's there. This one passes through negative 12, so if that's negative 6, and that's 6. This one has a slope of negative 4, and this one has a slope of 2. So this one is going to be something like that. And this one is going to be even steeper but going that way. So I think it's going to cross somewhere like that. So we're looking for this coordinate. Yes. It will be below the x-axis. So that's just a very rough sketch to sort of give you an idea of what we're going to end up with. So we're going to end up with a positive x number, negative y number, fingers crossed. Right, so the first step is we want to know when this equation equals this equation, and it's going to be at that point, so we're going to just write negative 4x plus 6 equals 2x take away 12. Right, because I've got a negative number of x's here and just want to get rid of the negative, we'll just add 4 to both sides. So I'm going to bring the x's over to the right hand side. Plus 4x, so that will cancel with that and we end up with 6 equals 2 plus 4 is 6x, take away 12, and then we're going to bring this 12 to that side, so I'll add 12, 6 plus 12 is 18 equals 6x, because that cancels with that. And then we'll divide both, not by x, by 6, divide by 6, and we end up with, let's put it, x equals 18 divided by 6 is 3. So then we're going to substitute x equals 3 into one of these equations. Let's go for this second one, simply because I'm going to be multiplying two positive numbers. That's the only reason. So let's change colour. So then sub x equals 3, y equals 2 lots of 3, take away 12, so that's 6. 12 equals negative 6. So let's just write this as a sentence. So y equals negative 4x plus 6, and y equals 2x take 12, intersect at our x coordinate, our y coordinate, negative 6. So that, it's not exactly accurate, but that would be 3. So yeah, so that line should be a bit slopier this way, so that it crosses there. Let's just redraw that. So that would be 3. So that is 3, negative 6, where these two lines intersect. So, just to recap that, as long as both equations are in this y equals in that form, in the mx plus c form, you make the two x sides of the equation equal to each other, collect like terms and solve for just x, and then, so that's the x part of the coordinate, and then you substitute that back into one of those equations. Let's just check that if we substituted it in that one, will we still get negative 6? Negative 4 times 3 is negative 12, plus 6 is negative 6. So that's a way to check if you've got the right number here. Either of those equations should give you the same y coordinate, because that's the point, that both of these lines equal each other. Make the equations equal, solve for x, and substitute that x value back into one of the equations to find the coordinate. Oh no, we already did that example. Okay, so that's where I'm going to leave this one. That is the end of that section of the textbook, and I'll see you in the next video.